Hello, welcome to Outmouse Labs. My name is Penny, and I'm glad you're here. Today we are going to be looking at PixelFalls and some of its new features in the 0.10 release. We're also going to continue on with our adventure game building tutorial. In some ways this is almost a reset of that because with the new features it was worth it to recode it. So we're going to go through each piece together. First of all, we have a new home screen in PixelFalls. This allows us to save things to the cloud, and there's going to be different types of accounts depending on, there'll be a free tier and the different types of pay tiers depending on what you want to do for your subscription. Each account will allow you to save a certain number of game files based on space requirements, and you'll be able to pull and share those with other people. You'll still be able to import and export carts just like before. Okay, so now the details. There we are. Sorry about that. You can add a description. You can apply categories. You can set some of the controls. So for instance, this is D-pad plus 2 buttons. We'll say save those details. And then it's saved to the cart. Just like before, if we go to game settings, we can drag and drop an image, or we can hit play, and you can hit Control-Shift-C. So once it loads up, you can hit Control-Shift-C, and then that becomes your cover art. So if we go to game settings, that's now our cover art. Just like before, you can choose your color depth and from a number of palettes, and this, I believe, is new from the last video I made. Frame rate, you can now set it to 30 or 60. The reason you might want to set it to 30 is for lower-end devices, mobile devices, it'll use less battery. 60 is going to look more smoothly, and since I'm a desktop developer, I'm going to go ahead and do that. Okay, tags have been moved to the game settings section. You set them and they are global, so you can apply those tags as an enum from a list whenever you build out a prop or a node. Okay, code editor. Not a lot has changed that's visible. However, a lot has changed under the hood. There's better IntelliSense, there's better code guessing, and very coolly, now when you create a function in your main Lua file, so for instance, my utility includes a room-based camera like the original Legend of Zelda, and animation, a simple animation function. Both of these now show in other code as native functions. So they don't make the little squiggly line, and you can pull some data about how to use them using the IntelliSense, which is so exciting. So for instance, there is my animate function, no squiggly line, no error, just lovely. Otherwise, it's pretty similar. You can still create nodes and props. You can still organize those in files, in file folders if you'd like. You can still change something as a node or prop. Looking at our nodes real quick, nodes are now, we can now do collision detection between a node that is instanced in code and a node that is instanced by the map. So for instance, my player is instanced right here using the spawn method. So player equals spawn player. The rest of my nodes are going to be instanced by the map. So for instance, my gates, my key, my lock, and my walls are all nodes. Those are being instanced by the editor. Now those two types of nodes or two types of instances can collide, which is lovely. Otherwise, this is still pretty much the same. You can still choose any sprite. You can still go into settings for our key, for instance, and set the origin point, set whether collisions are enabled, and if they are, what the collision box looks like. You can still have multiple colliders. None of that has changed. Our sprite editor still looks largely the same, although it's a bit more organized. You have everything you might expect from a Fantasy Console-liked engine, so sprite flags, a fully functioned 8x8 editor. There's our color palette that we set in game settings. That'll switch on the fly if you switch your palette. You can still import sprite sheets, and you can still try to auto-match the colors or just make sure that you have the right palette installed. And you can still add palettes in game settings. So that's all excellent. I still haven't used the tile set feature very much yet, but it is there. I do mention it in an earlier video, and I'm sure as I find uses for it and understand it better, I will make more tutorials around it. Our level editor, this is really important for today's video. Some things to note, we still have multiple layers. We have our base layer, our node layer, for instance. Our base is a tile layer, our node layer is a node layer. Actually going to go ahead and rename that as just node 1. Up here in map settings, we can set the width and height of the map here, and this is in map coordinates, so 8 by 8 squares. I will admit I didn't actually know how to do this at first. I had to ask, but you can increase the size of the editable map with these width and height right here. And the map, I think, is technically essentially infinite. It's just that you have to set what you want to be editing. There's other things you can note in here, the layer stack, so the order in which it's stacking, different things like that. The name, you can add new maps. But for now, we have one map, and on our map, we have walls, which are nodes. We have gates, which are nodes, left and right style gates. We have locks and keys, which are also nodes, and you see we do not have a player because we spawned that in code. We don't actually have any tiles yet, so maybe we will do something where we create some tile effects here on the video. Sound editor I have not messed with yet, and once I do, you'll be the first ones to hear about it, of course. All right, let's take a quick look at what we have. We play the game. So, first thing is you can see we have a fully animated in 4 directions character with movement. We also have full collision with our nodes. We cannot pass through the gate or the lock. We have the camera I mentioned. So this is what that camera code, which I'll go into detail, allows you to flip between screens very much like the original Legend of Zelda. And we can get our key and go down and around, and we can unlock the door. And then maybe there's a chest in here, maybe there's a victory condition for the level. So that is the basics. We're really getting there with our adventure game. Okay? So how did we do all that? Well, let's take a look. All right, close the key code and the lock code. In main, we create an instance of our player. We tell the camera to follow the player, and every frame we clear the screen, draw the map, and draw the player. You technically don't need this player draw if you're using a static sprite, but for animation you do need to set up a player draw. Utility code. Function cam follow. This is a piece of code that takes in an object, so a table, and the local cam x is set to the object's x divided by 128, and this is integer division. It'll always give an integer, a whole number. And then we multiply that by 128. We do the same for y, and then we set the camera to that cam x and cam y. The reason we do this is by doing this little formula, our object will always be on a map screen. If we divide that map screen by 128, we're guaranteed to get the map screen that object is on. And when we multiply it by 128, we set our cameras 0, 0 to the left-hand corner of that map screen. And no matter which map screen you go to, it'll snap to that, with the map screen being the 128 by 128. There are ways you could do this to make it prettier for sure, but this is definitely functional for what we're doing, and I think it looks pretty cool. Next up, animation. So I call this function animate. This is actually a reference to an old Love library, Love 2D library, which is another Lure framework, although this animate is much, much simpler than theirs. This takes in an object and a specific animation. We get the object sprite and we set it to the animation's current frame. We then tell our frame timer to go up by 1. Every frame, so roughly 60 times a second in this case, that object frame timer is going to go up by 1. If the frame timer is greater than the object's frame speed, which is going to vary per animation potentially, then the object's current frame goes up by 1. So every time that enough iterations have occurred, it'll go up by a frame, which is how we get our animation, because it's just flipbook frames. If the object's current frame is greater than the length of the animation table, because when we do hashtag table or # table, what we're saying is get the length of the table, then the object's current frame is going to go back to 1, so that it's a loop. And the object's frame timer will also go to 0, so that is also always looping around to count up to give us the number of frames. This is easier to see in action, so I'm going to show it to you in just a minute. Let's go take a look. So we say if the key right is being pressed, then we animate. What are we animating? The self, which is the player. and we want to use the animation self.walkRight. If we go up and look at self.walkRight, it's a table with frame 33, 34, and 35. If we go back to our function, essentially it sets it to 33. Then the frame timer starts counting. The frame timer is set to 0, and the frame speed is set to 8. So every 8 frames, it's going to count up. So 8 frames after 33, it's going to become 34. 8 frames after 34, it's going to become 35. 8 frames after 35, the length is going to be larger than the table, so it's going to go back to 33. It's really a pretty simple system. It just loops around and around, and you can determine what animation based on, say, what button you're hitting. Animate self-right, self-walk left, self-walk down, self-walk up. The next step here, when we add a weapon, just so you know, what we'll be doing is setting a state. So there's a move state and an attack state, and the animation will play based on the state and the direction. Okay, but that's for the future. All right, so we create our player by doing init self, which, remembering self is just a reference to the instance. We give it a speed, whether it has a key or not, a sprite, a current frame, a frame timer, a frame speed, and then whatever animations. In update, we always, at the beginning of our update, set the old X to the current X and the old Y to the current Y. This is how we do collision checks. Then we see, is there any button being pressed? If any button is being pressed, then we try to move, and we try to collide with a lock, which we'll get to. If no button is being pressed, we don't do anything. If we try to move and we try to collide, and we're not colliding with a wall, then we could try to collect any key or whatever collectible may be there. Finally, if none of that is possible, we set the self X back to the old X. So if we, for instance, hit a wall collide, so we hit a wall, we go back to where we started so that we never hit the wall technically. So the collision happens and then we are back, and all of this is done before we draw. So from the player's perspective, when they see it because of the drawing, all this has already happened and there was no movement. For drawing, we're drawing the sprite at self.sprite, self.x, self.y, and that self.sprite is being changed by the current frame in the loop. All right. For move, so we try to move, again, up in update, we try to move if any button is down. So a button is down, we check what button. Well, the first thing we do is do self.setSpeed. Self.setSpeed is a function that checks to see if the X key is being pressed. If it is, it sets the speed to 2, else it sets the speed to 1. That allows us to run. Let me show it to you here real fast. So, base speed, running speed. This is something you might want to disable, or I might want to disable when I release a game, because I'm not sure I really want the player zooming around like this. But for testing, it's great. And I might leave it as a function, or I might make it an item when you get the, haste boots, then you can run. So the set speed allows us to change the speed. So we set the speed every time we try to move. Then we check which button is down. We already know a button is down. Well, which one is it? If it's key right, then we animate the walk right, and we move to the right based on our speed. Same for left, same for up, same for down, right? And because we're adding the self.speed, when we change the speed, that's how we get the run effect. Okay. Function collect. So if self, has collided, tag.collectible, then do stuff. So what does that mean? If the self, so if the instance of the player, has collided, this is a function in PixelFalls, with a tag called collectible, then we create a local variable called colliders, which is the get collided entities. So give me a table of any entities that the player instance self collected with. If colliders 1, so if the first entity is named key, then we set key to true. And we destroy colliders 1. Once I have more items, let's say I have coins, it would be like if colliders1.name equals coin, then self.score plus equals 10. And then we would have points. That'll be something we add later. For right now, it's just looking for the key. But this is very extendable, meaning we can make it bigger and do more things very easily. All right, function wall collide. This is checking to see if we hit a wall. If self has collided, the tag wall, so anything with a wall, so things that have a wall, the lock has a wall, the gate has a wall, and walls have the wall tag. So all three of those will stop the player because it returns true. And when that returns true up here, it only keeps going if not wall collide. Else, it's going to set the player right back to where they were before they hit any buttons. So that's how we do collision. Function lock collide. So if self has collided tag.lock, then local colliders equals self.get collided entities. So once again, we're setting a local colliders to what was hit. We set the local variable lock to nil, and then we go through that list of colliders. So for I, so which is for interval starting at 1, for the length of colliders, and each one do this. So if colliders, if that list of entities at I, so for instance at 1, dot name equals lock, then lock equals colliders I, end. Else, it's going to, let's say there's 3, it'll go through and check 1, 2, and 3, and it's looking for that lock. Then it's going to say if self.has key, then destroy lock. Self.has key equals fault, right? If it doesn't find a lock, then it's not going to set it to the colliders. Actually, right now, if it didn't find a lock, I guess it doesn't crash because I've touched it without the key. Let's actually check that. There might be a bug here. Let's see. Nope, we're good. So in some cases, that might have actually caused a bug, but it doesn't here. So if the collider, so it looks for a lock, a named lock, and then sets the variable lock to that collider, and then you can destroy it. If it doesn't find it, nothing happens. And then we already talked about set speed. Okay, so that's our player. Next up, let's take a look at our key. It just has a name, key. Our lock just has a name, lock. So these could almost be props, but I need them to have a name, so they are nodes. Our wall is a prop. Our gate and our gate are all props, meaning that they have a picture, they have an image, they have a sprite, and they have a collision, and they have properties. So they have a collision box, they have properties. However, they do not have any code. So they're only useful because I have tagged them. Just to show that one more time, I have tagged them wall. So you can hit edit, choose. I have tagged them wall, and that's the only thing that they do. And because they have the tag wall, they set off our collide wall function, which means we cannot walk through them. So that's it. It's best to use props when you don't need any code because props are going to be a little bit more efficient. They're going to be smaller. They're probably a little bit faster as well, although I'd have to check with Chris to be sure. Okay, so that is how we put this together. We are really making some progress on our adventure game, and PixelFalls is really making tons of progress as an engine. Right now, as a reminder, PixelFalls is an alpha, and an early alpha, which you can join by joining the Patreon. That comes with access to the Discord. I'm in there fairly often. You can talk to me. Chris, the developer's in there. You can talk to him. There's also a bunch of other cool people. So it'd be great if you joined us. Just a few dollars a month, and it's helping this engine kind of make progress and come forward. Anything else I would add today? I think just to let you know, I'm going to be continuing to add on with this, and I think the next thing we're going to be looking at is maybe scoring, like collecting coins, and then maybe health and damage, and therefore an attack and enemies. So we're going to keep at it. All right, thank you so much. I'll see you next time, and happy game making.